Stanford University.
All right, let's get started. So welcome again to Lecture 5, CS193P. Today we're going to talk about how do you get your pixels on the screen. So views, drawing, and animation. First, a few announcements. So assignment 3 is due Tuesday, next Tuesday. That's the kind of the Hello Poly Plus, right? So get them in. Let's do it 11:59 p.m. Any later, you lose a late day. The Friday session for this week is starring Troy and Paul. They're going to do an office hour, super mega office hour. So if you want to go check it out, what room is it again?
200, 205.
So 200, 205 on Friday. And we've had some questions to our CS193P list asking how do you actually get on the auditors list. And the answer is, this is the website. So for those of you following along at home, I'll let you click on that link on the slides. And the final thing I want to bring up here is, so AT&T got in touch with us. They have a big competition that they run every year. This is the second year running. They have a competition for best mobile application. It's called the Big Mobile On-Campus Challenge, and it's worth $10,000 to you if you win. So check it out. It's right here, att.com, Higher Ed Contest. Take a look at what the criteria is, and I encourage you to participate. I believe last year the winners were Stanford students. So before I begin on views, can I just ask, any questions from last week, specifically about, the 4 different topics we have covered here. I found one quote on delegation from Apple's documentation. I thought this was a pretty good way of explaining it, which is, delegation allows one object to act on behalf of another object. So that, hopefully people have gotten the hang of this after assignment 2, help clear some of this up. But any questions? Yeah. So the question is there a good way to, an easy way to rename your outlets in Interface Builder? And when you right. So yeah, if you rename them in Xcode, in the header in Xcode, that'll actually get picked up in Interface Builder the next time you save that file.
But all the connections that I made would still be...
No, the connections you make would. So if you start with a spelling mistake and you get pretty far in, you live with a spelling mistake. No, don't live with the spelling mistake. Make the change, make your connections again. And, yeah. Any other questions? Okay. So today's topics, once again, so we're going to talk about views, drawing, how to draw text and images, and animation. We'll get through that as well. Animation's really fun. I love that one. So here we go. First, views. So what is a view? Well, a UI view, as you've probably seen in the class already, is just a rectangular area on screen that knows how to do some view-related things. It knows how to draw content into a rectangle. It knows how to handle events. So it's a subclass of UI Responder. So UI Responder is a class that knows how to receive touch events and forward them on. So UI view inherits from that. And views are arranged hierarchically. So you have a tree of views. Every view can have 0 or more subviews, and every view has a superview. If that view has been put into a superview, it has a superview. And the root of that tree is a UI window. So every view lives inside of a window. UI window really is just a subclass of UI view with some additional functionality for to know about how to, being a top-level view. You can also, from any view, you can ask for its window. So if you're a UI view, if you have a subclass of UI view, or you're pointing to a subclass of UI view, you could say, self.window, self.view.window, and it'll always get you to that top root level of the view hierarchy. And there's only one UI window for an iPhone app. So you know Windows, you know Mac. Apps can have multiple windows. On the iPhone, there's one, and it contains your entire view hierarchy. When you create a project in Xcode, it also adds that UI window for you by default and sets up your connections with the application. So So view hierarchy manipulation. So how do you add subviews to other views? The easy answer, which we talked about last week, was to use Interface Builder, and I'll get to that again. But if you want to do this programmatically, there's a few different functions you can use, right? You can add subview, and every view allows you to add subview. You can remove from superview, so you don't actually tell a view that you want to remove its subview. You actually have to tell the subview to remove itself from the superview. And you can insert them in different places inside of a view hierarchy. So just like if you ever use any illustration software, there's layers. There's also different layers of subviews. So if I can place one view on top of another, and it'll actually cover it up. So you get the ability to say insert subview below a subview or insert subview above a subview, and you can swap them as well. Yes?
When you do add subview, does it default to on top, or?
Yeah, when you add subview, it puts it on top of everything else. So, yes?
I think this was mentioned before, but what's the advantages and disadvantages of doing something programmatically versus in Interface Builder?
Okay, so the question is, what's the advantage of doing things, advantages or disadvantages of doing things programmatically versus an Interface Builder? It's really, the best way, it's a matter of preference, and it depends on when, what you're actually trying to do. For now, and for the kinds of things you're doing in this class, Interface Builder makes it really easy to lay things out. And in general, Interface Builder makes it really easy to lay things out, and it makes it really easy to point things to each other. If you need to build something dynamically, that's easier to do in code, right? So let's say you have a view that contains n subviews, and n is dependent on some variable. Then that's the kind of thing you would want to do programmatically, right? So you can do everything in either case. Well, you can do everything you can do in Interface Builder, you can do programmatically. So now view ownership. So superviews retain their subviews. So when you create a subview and you stick it inside of another view, that gets retained, and it's okay to release it at that point. So that also has a caveat, which is often a lot of views are only retained by their superview. So be careful if you're manipulating a set of subviews, and let's say you take a view out of a superview and you want to do something with it and put it back in or put it somewhere else. If nobody else is retaining that subview will get released, and poof, it's gone, and you have bad memory on your hands. So if you need to take it out of a superview and nobody else is retaining it, do a little retain before you take it out, and of course release it if you do that. And the last thing I want to point out here is that every view has a property called hidden. So you can tell a view that it should no longer be displayed, which will also tell all of its subviews that it should no longer be displayed. But it keeps it in the hierarchy. So your hierarchy doesn't change, just the drawing code knows to skip that view and its subviews. So now let's talk about some actual drawing code. So there's a few different structures here that we need to know about. CG point, CG size, and CG rect. Now CG point, the parameters in a CG point are x and y, so that specifies location. CG size specifies width and height. All of these are floating point values, by the way. And then the third one here is CG rect, which is actually a CG point and a CG size, and specifies a rectangle. And you'll see this used a lot. Whenever you're talking about drawing, it's usually in the context of a rectangle. Whenever you create a view and you need to initialize it with a frame, we'll talk about in a sec, you do that with a CG rect. So how do rects and sizes relate to each other? Well, here it is. A CG rect has a CG point, and the point in this example has a x of 80 and a y of 54. So as you see here, the x offset is 80, the y is down by 54. And the size, well, the size relates to the rectangle, so 144.72. And this actually points to the next interesting topic here, which is, well, actually in two slides. The first is, how do you actually make a CG point? How do you make a CG size? There's this convention here where we say CG point make, CG size make, so it's the structure followed by the verb, in this case, which is make. And you pass it the parameters. So CG point make takes two floating points, CG size make takes 2 floating points. And CG rect make actually takes the 2 floating points for the point, followed by the 2 floating points for the size. In other languages, you may have seen they take top left, bottom right. In this case, we're actually taking origin XY followed by size, width, and height. So. Now here's the other point I wanted to make, which is the coordinate system for UI views is that 0, 0 is in the top left corner. A lot of desktop systems do this so that origin is down the bottom left. And that has its advantages and disadvantages. I love this. Every time I go back to the desktop, I get frustrated because I wish I had this, which is that we all read from top to bottom, right? So especially with text, you can grow your text downwards. You place it with respect to the top pixel on your screen or in your window, and then of course it's pretty common convention that everything is 0 on the left. But yeah, so 0, 0 is top left. Everything is with respect to that origin. And so here's a UI view inside of that origin. Starts at 0, 0. Yes?
Are we allowed to have negative coordinates? Like, so say I had a rectangle and wanted to shift it over.
Yep.
I could shift it off the screen or
yep.
whatever.
So question is, can we have negative coordinates? Yeah, the answer is yes. I believe it's an infinite space in all directions. And the more negative you go, the more off screen it's going to go. So location and size. There are 2 rectangles that you'll often find associated with a view. There's a frame and there's a bounds. Okay? Now, the frame specifies a rectangle of a subview with respect to its parent. Okay? So in this case, if I have a view that starts at the origin, has a width and a height, its frame is 0, 0. And in this case, its bounds are 0, 0, 2. Well, what's bounds? Bounds is the rectangle of the view with respect to itself. Okay, so frame and bounds makes a little more sense here. When view B has a frame that's offset by 200 to the right, 100 down, and a height of 200, width and height of 200 and 250. But it has a bounds of 0, 0 with respect to itself. So let's look at that again. So in this case, view B, its origin is its own top left corner in its bounds. But its frame is 200 by 100 from its parent. Does that make sense? So there's really, it's 2 different frames of reference here. One is with respect to how it's positioned to its parent. The other one is how it looks to itself. So another question, one question I've heard brought up before is, does bounds always have to start at 0, 0? The short answer is no, because you can crop a view and stuff like that, and it could still have bounds. But without worrying about that, those are the 2 things you have to know. Frame, the frame is a view with respect to its parent, and the bounds is the rectangle with respect to itself. So which to use? Again, a couple examples here. If you're using a view and you want to ask for its rectangle, you typically use frame. If you're implementing a view, meaning if you're drawing or responding to events for a subclass, you're looking at your own bounds. So you're always looking at your own bounds, or you're looking at your subview's frame. Yes?
Can a subframe go outside the bounds of its superframe in any direction?
The question is, can a subframe go outside of the parent's superframe? Yeah. So the answer is yes. You could go any of these contexts are always infinite in all directions, and you can go outside. For bounds, you can even draw things that are outside of a rectangle of a view's own bounds. And I believe there's a way to say, yeah, there's a clips to bounds, so you can say, don't draw outside my own rectangle or allow it. So, yeah. So now, how do you create view? Any questions on that, on frame versus bounds? Easy to trip up on that, but it's really useful once you get it. Yeah.
Well, actually, what you just mentioned
If you don't clip, it'll draw outside of its bounds. Right. Okay.
Just a question on like rendering. If you drew like say 3 rectangles on top of each other,
Right.
does it actually render them one at a time, or does it sort of?
So the question is, if you have 3 rectangles that are overlapping, does it draw each of them? And I think the answer is the view system looks at it, unless let's assume no opacity, or sorry, yeah, no, full opacity, excuse me. Let's assume no transparency. So I believe the view system is smart enough to look at the top view and say, you get this rect, look at the sub view, and then say, it goes from the top in. Look at what's uncovered of the rectangle below it, and say, you get this rect, and it goes further. So I think if you have a rectangle that is completely obscured by another one, the one underneath will not get called to draw. So creating views. Well, how do you get them in? We've played with this already. You get them in via Interface Builder is one way to do it. There's several different tools you can use in Interface Builder, including a UI view. If you want to drag in a button, you drag in the button. If you want to drag in a slider. But if you want to create your own custom view, you drag in the UI view object from the palette, from the library. You put it inside of your window. And then you set the class on the view. Right? So by setting the class, you're telling Interface Builder, it should know which classes are available as long as that nib is in your project that also has the other classes. And by setting the class, it automatically inherits all of the drawing behavior that you're going to implement. So it doesn't know in Interface Builder how to actually draw. That's all in code. That all happens at runtime. So what you actually see is just this big rectangle, this big gray rectangle. Now it also does things. So I told you that you can have this hierarchy, right? So you can stick one view inside of another view. So if I was to take a second UI view and I was to drag it somewhere in here, it'll give you hints about where in the hierarchy it's trying to put it. So if you were going to drag it into the window, I believe there's a green or red highlight around the window to show you that that's the parent that's about to accept the view. If you drag it into this thing will get the highlight, and you can figure out your hierarchy that way. Yeah?
So since you have to say what the class is, what is it doing over there on the left when you're choosing one of those? Are those not different classes?
So the question is, why do you have to set the class if there's different classes available in the library? Well, the library includes all of the UIKit classes. So it's all of the. In order to get an object in here, there's more code you have to write, including you need to define how the inspector works. We're not going to get into that, but basically these are all the views that are available in UIKit. Anything that you've made available by subclassing will not appear here. You do that here. Does that?
My question, I think I have a slightly different question, which is, given that those exist,
Right.
wouldn't choosing one of those already be a very specific act in terms of a class?
So the question is, isn't by choosing one of those, don't you automatically get a specific class?
Yeah,
Is that right?
maybe
Well, yeah, it does. I think so. So if you're taking a UI button, there's actually a UI button in there. If you take a UI slider, there's a UI slider in there. And when you drag those in, you get the view and you get the behavior of a slider and a button, right? So these are actually UI buttons that got dragged in. Now, those are subclasses of UI view. The difference is that for your own subclasses, they won't appear in there. So if you want your own subclass, you have to drag the generic UI view and then tell the view that it's actually a member of your class.
So maybe that's what I didn't understand. That center step, that's only for your own, the things that you define.
Right. Yeah, this is for subclassing. This is for setting one of your subclasses, essentially. Right. Yeah. So now manual creation. We've talked about memory allocation in the past and how every object has an init method. For views, the way you initialize them is you actually call something called initWithFrame. And it's the designated initializer for the class. So we touched upon how different classes could have different initializers that take different parameters, different arguments. The one that you want to use for UI views is initWithFrame, and it takes a CG rect so that you can specify its frame with respect to its parent. So here's an example of creating one. We say initWithFrame, and we actually created a frame right above with CG rect make. We add it to the window. We can set any properties on the view that we created. In this case, it's a label. And then since we've added it as a subview, we don't need to retain it anymore. We don't care about it. We're not trying to. We're never going to talk to it again. It's just a label. So we release it, and we let the super view handle the memory. So does that make sense? So now defining custom views. Well, let's say, yeah.
So CGRect, is that like a struct?
CGRect, yeah, it is a struct actually. So CG size is a struct of 2 floating points. CG point is 2 floating points. And then the CG rect contains a CG size and a CG rect, or CG point. So defining subviews, defining custom views, excuse me. So you subclass UI view to start. You get all the functionality of UI view. And then if you're just drawing, the main method that you're going to override is called drawRect. And it takes one argument, and that argument is a CG rect. And the other methods that you can override, if you like to, are touches began, touches moved, and touches ended. Those are all from UI responder, but of course, UI view is a subclass of UI responder. And inside of these, you can handle any touch events, right? Now, we talked about in the past, just really briefly, an event contains one or many touches and a type. So if I put a finger down, that's a single touch of type touch down. And there's a touch up, and there's a touch dragged. So this is how you override.
Is that also true of gestures? Gestures would be in there, or?
The question is that true of gestures as well? And I believe you have to implement your own. Yeah. So, yeah, right. Gestures, I think you know, swipes you have to interpolate yourself and decide that that's a swipe. For some classes, they do that for you. But if you're trying to get your own behavior for swipes, you do that yourself. So now how do we draw views? Again, drawRect. This is what you're going to override. By default, drawRect on a UI view is an empty implementation. It doesn't do anything. And if you don't override that drawRect, the background color of the view, background color is a property on the view. The background color is used to fill that view. So if you want to implement a custom view, you override drawRect. The rect is the area that it wants you to draw in. And when is it OK to call drawRect? Does anybody want to guess? When is it OK to call drawRect? Never. Don't call drawRect. If you're implementing a subclass and then you're implementing a subclass of that subclass, the exception, of course, is to call super on your superclass's drawRect. But you never call drawRect on a different view. There's this view hierarchy that handles all that for you. And so it's good to be lazy about this because the system does everything it can to optimize performance at launch time, at runtime. The example of two rectangles overlapping with each other, the drawing engine is smart enough to not call the hidden rectangle because the user's not going to see it. It's just wasted processor time. So don't call drawRect. If you really want your view to be displayed, to be redrawn, what you call is setNeedsDisplay. So you say, let's say you've got, well, in our Polygon, in our Hello Poly assignment, you change the number of sides and you want that view to redraw. You tell the poly view that setNeedsDisplay. And then the next time through the run loop or the next time the view hierarchy decides it's a good time to draw, it'll call drawRect on your class. OK, so Quartz Composer, Quartz 2D and Core Graphics are the basic drawing engines underneath the hood. And there's a lot you can do here, and we're going to touch on some of it. UIKit's fairly limited in terms of actual drawing, actual pixels and points. And so what we have is we have a UI rect fill and a UI rect frame. And UI rect fill, as you can guess, is like, you know, it's like filling the entire rectangle, and frame is stroking the entire rectangle. But CG is a C-based API. We'll look at some of these in a second. It's not Objective-C. And CG and Quartz 2D, they're powerful. There's a ton of stuff you can do with this stuff. There's paths which define a path, right? A set of lines and curves. There's colors, fonts, painting, transformations, etc. So all of this happens within a graphics context. When you override DrawRect, you're actually drawing in something called a graphics context. It all gets set up for you before you get called. So you never, well, in general, you don't need to create your own graphics context. There's an exception, which we'll talk about in a sec. But when you're drawing, you can get your current graphics context using this UI graphics get current context. You can then set different properties on that context. So you can set fill color and point size for a font. You can set the font. You can set the width of a line. And then you go through and you actually start drawing. Another point here is don't ever cache a DrawRect because they're created for you on the fly. So you don't ever want to keep it around. It's useless to keep it around, and God knows what's going to happen if you do. So there's some CG wrappers here inside of UIKit that are convenient. You may need to refer to some of these CG structures in your UI, in your Cocoa world. Putting them in arrays and stuff like that. The ones that are interesting are UI color and UI font. So UI color lets you set, in this example, you can set, so I say, red color. Oh, first actually, UI color's got a bunch of default methods. There's red color, blue color, black color, yellow color. You can create UI colors with different RGB values. You can create colors with different alphas, stuff like that. But there's also different things you can do that will tell the context to set itself properly. So if I say red color set, it'll set the color for filling and for stroking. I can say set fill and I can say set stroke on a UI color. And then of course a UI font, I can get that system font by default is Helvetica. There's some small set of fonts available on the phone. I believe you can also bring your own in. But again, with respect to CG context, you can tell your, well, in this example, that's a bad example. But this is actually setting a font on a label, which is a UI view object. Yeah?
So is there a list, is there some place we can look at the list of fonts that are available on the phone? And if we wanted to bring in our own fonts, do we install it on a per application basis?
So the question is, where can you find out what fonts are available and how do you install them if you want your own? I don't know exactly the answer to that. I'm sure it's in the documentation. If you search for font in the Xcode help, I'm sure you'll find it. And as far as installing them, well, you can't really install fonts system-wide. So if you wanted to bring in your own, it's probably as a resource inside of your bundle, inside of your application.
You can't use CG. It's a lot of work to use a custom font.
So it's a lot of work to use a custom font. But yeah. All right, so here's a quick little DrawRect example. I'm going to, in this case, we're going to draw a, what is this? It's a square. OK. So I'm going to, we set the color to gray. So we start by taking the convenience gray color UI color, and we say set. So we set the color for the context, and then we say rect fill on the bounds. And the bounds is the entire rectangle that was requested of us to draw. Then I want to draw a square within my bound. So I'm going to create a CG rect, offset by 10 and 10 with a width and height of 50 and 100. And we set the color for the context. And then we say UI rect fill, and we fill a square. And then finally, we say black color set, and we draw the square. So here's what we got. We have our whole background, which is drawn in gray. We have a smaller square that's drawn in red. And the frame is drawn in black here. So notice the difference between fill and frame. Yeah?
How is CG different from OpenGL?
Sure. So the question is, how is CG different from OpenGL? It's a, I believe it's based on, it's a level above OpenGL. So I'm not sure how the implementation is underneath, but it's a different set of APIs. If you're trying to do, you know, things you're familiar with in OpenGL with animations and shading and all that kind of stuff, you're probably best to stay in OpenGL. If you want to do simpler things like that are higher level, like patterns and lines and rectangles and some basic shapes, you can do that in CG. Anything I should add to that? Okay. Bless you. So now, how do we draw some more complex shapes? This is always the way you're going to do it. You're going to get the current graphics context. You're going to define your path. The path, again, is the if you have a pencil in your hand and you drop the pencil and you make a bunch of motions, that's your path. You can even lift up your pencil and then drop it somewhere else and make some more motions, and all that's contained inside of a path. So you set a color, then you can either stroke or fill that path and repeat ad nauseum. So here's a couple examples. These are actually just Keynote paths, so this is the lazy way of doing it. But Core Graphics does define some shapes. So it defines you know, square and circle and God knows what else, probably octagon or something. It's made of lines, arcs, curves, and rectangles. So you can have straight lines, you can have curves with different you know, Bezier paths, right? And again, the way you do this is you actually draw your path and then you tell the context that it should actually stroke it or fill it. So here are a few examples of functions that you can use. So the CG, there's two different ways of doing this. There's CG context and CG path. The CG context calls, they do it on the spot. So as you're telling, you know, CG context move to point, internally it's like there's a pencil that's actually moving to that point. And then when you say line to point, and then it then draws that immediately. The difference between that and a CG path is that the path will contain that drawing algorithm until you tell it to draw. So you can say CG path move to point, CG path add line to point, and it doesn't actually draw that line. It just puts it inside of this path object. And when you tell that path to draw, that's when it would actually will. Quick little path example here. So you know, we're going to set the color of the context to gray, and we fill the background. Then we say CG context begin path. Okay, so we're starting a new drawing path. We say move to point, context 7510. We say add line to point, so it goes to 10, 150. And we say add line to point 160, 150. And then we say close path. And then we draw, right? So first we say set fill, then we stroke, and then we say draw. Can anybody guess what this is actually going to draw? Come on, everybody's done math, geometry. 7510, we start somewhere over here. We go to 10, 150, we go to 160, 150, and then we close the path. What we get is a triangle. Everybody knows triangles. Sesame Street. Okay. So if you want to find out more about this, you take a look at the UIView class reference. Look at the CG context stuff. There's all kinds of documentation that's very helpful in the Apple docs. And, of course, plenty of samples. You're going to need to know this for your assignment 3. So, yeah, get comfortable. Yes?
So then what are the benefits of creating a path and using it over doing it piecemeal? Is it an efficiency?
If you just do it in the spot like that last example, I don't know if there actually is an advantage. But the one thing you can do with the path is you can reuse it. So the question is, what's the advantage of using a path versus just drawing in place? And I believe the advantage is that you can reuse that path, right? So can you save the path? Sure. Yeah, I'm not sure if you can save the path, but.
So you can reuse it just for redrawing and refresh, say? You wouldn't be able to shift and reuse it, right? So it's reuse it quite literally.
Well, that's what I think you can do, actually. I believe you can shift and reuse it. I'm not 100% sure on that. Yeah, we'll look offline and we'll talk about that more. So now images and text. How do you draw images and text? Well, first let's talk about what's a UI image. Well, a UI image is a UI kit representation of bits of an image. Now you might store that image on disk, or that might come from memory. Here's a few different ways that you can actually instantiate a UI image. If the UI image is included as a resource in your application, and this is probably the most common use unless you're doing some kind of network-based application. If you want to draw something that's in a resource, you use image named. Image named. So UI image is a class method, image named, and then an NS string that specifies the name of the file in your bundle. So this includes the extension. So if I have myimage.jpg inside of my bundle, this will actually create a UI image for that, and then you can pass it around, do what you want. It does some caching as well, so that's pretty handy. You can also read from disk. So you can say init with contents of file, and you can also init with data. So let's say you're pulling images off the network. You can say image with data and pass it the big blob of data that you got off the network, and it'll do the right thing whether you pass, PNG, JPEG, GIF. There's different formats that it supports. So. Now, if you want to create an image from something that you've actually drawn on screen, you can do that too. And that's not much different than if you were to actually draw. The difference here, this is the special case where you create your own context and draw into that context. So if you really want to do this, if you want to take a view and turn that into an image that you're going to send up as a screenshot or whatever it is, the first thing you do is you create your context, then you draw. Then you capture that context as a bitmap and you clean it up. So how do we do that? Well, here's an example. I have a function called polygon image of size. I want to create my own context, so I say UI graphics begin image context. I say UI graphics get image from current context, and this context is the current context in your rendering tree. And you can say end context, and then that'll package it up. And you can return that as a UI image. So what you actually get out of here is a UI image. And then you can convert that into different data representations if you want to send that back up to the network. So if you've got something in a bitmap context and you want to send it as a JPEG, here are a couple different functions you can use. So PNG and JPEG. And if you need to get a CG image ref, if you want to use that image in CG calls, you'll see there's some CG calls that actually do things with images. You can actually get a CG image from a UI image with the CG image property. Yeah?
So what would be some typical reason you'd want to do something like this?
Well, the easiest answer is, the best example I can think of is you want to send a screenshot. What you do is you actually, you tell your tree to draw inside of your context, and then you've got a UI image that you can use. The question was, what's the reason you would want to do this?
Not super common.
Yeah, it's not super common. Yeah, it's not very common. You may want to do some things on screen with, I don't know, let's say you wanted to, for some reason, not get your view. You have some complex view hierarchy, and you don't want to have it redraw over and over. You know it's never going to change. You could, turn that into a UI image and move that around instead. But again, it's probably, there's other ways of accomplishing that. So, does that help? Okay. So now drawing text and images. If you want to draw text and images inside of your DrawRect, you can do that. There's 3 methods on UI image: draw at point, draw at rect, draw in rect, and draw as pattern in rect. That you can call in your DrawRect, and they'll put them in the current context. And you can do the same with NS string, but there's a better way, right? So instead of having to draw all these yourself, we should use the UI kit subviews. There's 2 in particular. There's UI label and there's UI image view. UI image view is for images, UI labels for text. Let's look at this, right? How do I implement this case where I've got this is my view right here. It contains the shape and it contains the string. Instead of in my DrawRect having to draw that text, I could actually stick a label there, right? So the goal here is to have one view that contains both the shape and the text string. And instead of drawing them directly with those methods I just showed you, we actually stick a UI label in there as a subview of your polygon view, and then everything will animate correctly and be anti-aliased correctly and all that stuff. So a UI label, this is the string drawing UIKit class, UI view subview. It knows how to draw text. It has all kinds of different properties, including font, text color. The shadow is really useful. You'll actually notice shadows used all over the place on the iPhone. If you look at anything that looks like it's etched into a metal background or a navigation bar, that's all a 1 pixel white shadow or black shadow. And that's all built into UI label. And text alignment, so if you want to center or shift, adjust left, that's all there. UI image view, also very useful if you want to draw an image to screen. You put a UI image view down and you set your image, and the image is a UI image. It also allows you to set up an array of images that it'll animate between. So if you remember back, 10 years ago, the animated GIFs were all the rave. I think they still are for some things. You could do that here. And you can have it repeat ad nauseum over and over. And then there's another property here that I wanted to point out, which is content mode, which is actually on the UI view. But content mode will tell the UI image view how to draw its content. So the examples here are, you can say center. So UI content mode center. You could say scale. You could say fit to fill. There's a few different ones here. Align top, stuff like that. So this is, this will help you align and scale your images inside of a UI image view. And then the last one I want to point out, which we've all played with, is UI control. There's all kinds of subclasses of that: UI button, UI text field. The interesting thing here is that, UI button handles a lot of the same things that UI label does. It needs to know how to draw text. It needs to know how to put a shadow. And so those things are done for you. So you don't actually have to implement your own draw recs to make a button, right? You use the styles that are already available to you. So, all right, so view properties and animation. Well, one thing you get almost for free in UIKit is the ability to animate views, to move them around, to change their size, to change their opacity. Here's an example where I have a set of controls that I want to disclose. When I toggle this switch, the on and off, the advanced options switch, I actually want to show more controls. And I want it to animate, right? So if I turn that on, I want to show those two controls that are underneath. Now, traditionally, you may be used to, you have to set up a timer, you have to move the pixels and redraw and keep track of where you are, stuff like that. This actually makes it, UIKit actually makes this very easy. So UI animation, there's a few different properties that are animatable, and I know that's not really a word, but the properties basically, for free, you get the ability to say, given the starting point, here's the ending point, this is the new value I want it to be, and here's how long I want it to take to do that animation. So the properties here are frame, bounds. So frame, I can tell the object to move within itself. Bounds, I can have the object crop within itself, all animated. Center, again, movement. Alpha, so fading in and out. The way I do this is I create these animation blocks around when I set a value. So if I'm going to change the frame of an object and I want it to move from point A to point B, I start an animation, then I set the value, and then I commit the animation. So let's look at that. There's a few different animation options. Before I get into the example, a few different animation options here. I can tell the animation that I want to wait 3 seconds. I can tell the animation that I want it to start at a specific time. I can tell it how I want it to actually animate. So let's say I'm moving from point A to point B. Does it move in a linear motion? Does it accelerate and then decelerate before it gets to the end point? Does it accelerate the whole way so it just kind of speeds up to its destination? How many times does it repeat? Does it auto-reverse on itself? So if I'm doing that same movement, I can easily have it go from point A to point B, back to point A, and back to point B. That's actually how, if you notice the iPhone, when you want to move the icons around and you hold down your finger, you see all the little icons jiggle? All those little icons jiggling are transformations that are repeating on themselves. So pretty easy. It's very few lines of code, like 5. It's really easy to do this stuff. So here's an example. In this example, what I'm going to do is I'm going to change the opacity, the alpha of the view, and I'm going to change the frame of the view. So what I do is I start animation, and a begin animation actually takes a string, so you can identify it later if you want to. You don't need to do that. You can pass in nil if you want to. You set the animation duration. By default, I believe it's a half second or a second. It has some default amount of time. But you can set it to be whatever you want. Then you just set the values, right? You don't do anything except set the values. You say options view alpha equals 1. And if it was 0 before, it's going to fade in. And then I set the frame. And again, all I do is I take the old rect, move it by 200, and then set it back. And that'll actually reposition it in a 0.3 second period of time. And when I'm done, I commit the animations. And by committing the animations, you're telling it to go. You can also ask to be notified when an animation finishes. So if you want to do one animation, and then when that animation completes, you want to do a second animation, you can do that. So you can set a delegate. Here's another example of delegate that's very useful. You're actually, you're not subclassing UI view to get the behavior of notification. You just tell it to let you know. You tell it who your target is, who your delegate is, to be notified when an animation completes. And then you implement 2 functions. An animation will start with the context, animation did stop, and I don't know what that finished is. Okay, so finished is a Boolean that'll tell you if it got canceled or if it succeeded. And then context, which is what you get passed in when you began the animation. And then you tell the view that this is the selector you're going to you want to be called with, and this is the for starting and stopping. So this is easy way to be told when something starts and finishes. So how does this work? Is drawRect repeatedly called? Do you have to draw for every frame of the animation? And the answer is no. Under the hood, there's something called layers, which we're going to just touch upon really briefly. But basically, they're bitmaps of what you last drew. And when you tell it to move position or to scale, it actually just takes that bitmap and moves it for you. So you don't have to redraw. And you don't need to set up any kind of timer. It does it all for you. It's all under the hood. And yes, it is magic. So here's a little information about Core Animation. It's a hardware-accelerated rendering engine. I think a lot of it is on top of OpenGL, once again. Every UI view is backed by a layer. So when you draw, you're actually, the context gets placed into a layer. And the results are cached, so you don't get called on drawRect when you don't need to be called again. And then the animations actually occur automatically for you by manipulating these layers, which are all done under the hood once again. So before I move on to transformations, another thing I want to talk about with these animation blocks is that you can take over an animation before it completes. And in this example, we set the alpha. It starts at 0, it sets the alpha to 1, and then we assume it's done, right? I can hijack that in the middle, and halfway through, somebody does some action and it wants to go back to 0. All I have to do is start a new block and set the value back to 0, and it takes over from where it currently is. So if it's halfway from fading from 0 to 1, it actually stops halfway and goes the other way. And it's the same for movement. So if I'm trying to go from position A to position B, and halfway through the user's done something that makes it want to go to position C, it just picks up where it was and goes to where you wanted it to go in the same amount of time. So very convenient. All right, back to where we were, which is view transforms. This may be in your project. Is this in assignment 3? Okay. Ignore that. There's another way you can transform a layer back to CG land for CG calls. You can create an affine transform. By default, every layer actually has a transform property, and that transform is the identity transform. And if you remember from geometry, identity transform is a matrix of ones and zeros. Basically, the layer doesn't transform at all, right? Excuse me. I'm not going to answer that. OK, and then the structure for doing this is the CG affine transform. There's a few different things you can do here. You can scale, you can rotate, and you can translate. And then you can look at these on your own time. So scale takes an X and a Y scale. Rotate takes an angle. And translate is position offset. I believe that angle is in radians. I think it's in radians. And if you want to find out more about animation, take a look online. Once again, Core Animation Programming Guide for the guts, and the iPhone OS Programming Guide. Look at modifying views at runtime. That'll talk a lot more about the begin animation, commit animation stuff that we looked at. So that's it for views. Before I move on, does anybody have any questions about this? The animation stuff's pretty powerful. When I thought I was going to run out of time, so I didn't bring a demo. But when you see this stuff in action, my jaw dropped. I was amazed at how little code you had to do to get these complex animations to occur. Watching an object go from point A to point B in a zigzag fashion. Actually, if you've ever seen the screensaver on the Mac, where it's a bunch of album covers, and each of the album covers flips at different times. All that's done in Core Animation, and it's some of the same code you've seen here. And it's basically a bunch of different layers that flip, and the amount of code to implement that is tiny, tiny. So take a look, play with it, enjoy it. I think you'll find some useful stuff.
One quick addition. It's probably worth mentioning that when you're using these UI view animations, you're using Core Animation without interacting with it directly. So you have the option to drop down and use Core Animation directly if you want to, but you also have this high-level interface via UI view, begin animations, commit animations, where you don't need to actually interact with Core Animation directly. So that's really powerful. And like Al said, it's really a ridiculously small amount of code to get complex animations going.
Yep. So any final questions on views before I move on? Views or animation? OK. So the last thing I want to talk about here before we go is some hints for assignment 3. Actually, just one hint for assignment 3. Assignment 3 asks you to do something that we haven't covered yet, which I'm about to cover, which is saving your application state. It asks you to quit your app, and then when you restore, you should be at you should have the same number of sides as when you quit. And the way you're going to do this is with something called NSUser defaults. And NSUser defaults is basically, it's a free way to save preferences in your app. You can save all kinds of different types of data. Here's some examples here are integer. You can save an object. An object can include arrays, dictionaries, numbers, strings, dates. I'm sure there's anything that responds to this NS coding protocol, which I'm not going to get into. But you can also say float for key, Boolean for key. The way this works is, so there's a property list that gets saved off in a user area for the phone. And when you store values inside of the NSUser defaults, it automatically writes to that. and when you read them, it reads them back. So use this. This is the answer to that part of the assignment. Find an appropriate time to restore and save that.
Is there a limit to like the size of the data?
Is there a limit to the size of the data? You generally don't want to put large items in there. I mean, you're not putting huge graphics or anything like that. It's not your database. It's probably not fast enough to be your database. But it's great for little pieces of state that you need to keep around. So.
The type on object for key and set object, those are IDs instead of its, just in case anyone gets confused.
Oh, right. Right. So I made a mistake here. So object for key and set object for key, these should not be integers. These should be IDs. Again, ID is your generic untyped object. But the first one's right. I got one of them right. And then again, it's all key value based. So you save, you do it for a key. It saves it by that string, and when you want to get it back, you get it back. So if I save age, I can set I can set it as age, and when I ask for it back as age, I'll get it back again. So, yeah.
So I'm having trouble seeing. You say the first one's right, but one of the second one's what's the difference?
Right. So, well, my error here is, this is integer for key, so it obviously takes an integer and it returns an integer. In the object case, it's not supposed to take an integer. It's supposed to take an object. And it takes an ID instead of an NS object, but that's what it takes. Any final questions? Yeah?
Give an example of the identity stuff.
Sure. Code example?
Yeah. Or like,
Oh, why would you want to do that?
no, I mean, you can, like, on the iPhone simulator.
Can build one for you? I can build one on the fly. Sure. All right, I'm going to build a UI animation example on the fly here.
You just do like a moving box or something.
Yeah.
And add an ID or whatever.
Okay, so what I'm going to attempt to do in this short period of time, and I'm the one that's evangelizing that it's so easy to do, so I'm going to do it, is I'm going to start with a view that has one subview, and wherever I click, I'm going to want that view to just move to that point. And if I click around, I want it to just keep going for every time I click. So let's see if we can do this really quick. So
You want to skip the touches, you just have it like going back and forth.
that's a good idea.
And I was wearing handcuffs while he's doing this.
Handcuffs, yeah. Underwater. All right, so I'm going to start with, what am I doing?
You just do
View-based.
window.
View-based application. Choose.
Do them view controller stuff, maybe.
Oh, that's view controllers?
Yeah, window-based app.
Window-based application. Okay, we're going to call this,
Untitled.
yeah, touch follower. Stalker. I'm going to call this stalker because the object's going to follow me around. Okay, so let's pull up our nib. Main window.
Can you get a copy of this when you're done?
Can we get a copy of this when I'm done? Jeez. All right, sure. Okay, so again, here's an example of when you create from a template, it gives you a window by default. My resolution on this is tiny, so I have to move things around here. But what I want is a, so small, UI view. I'm going to put a UI view in there. Okay. And let's see. I'm going to take another view. And this mouse is not responding. I'm going to change the dimension so it's just a small little rectangle. So there's my, in my inspector palette, there's 4 different tabs here. I'm going to go to the size tab, and I'm going to take it down to, let's say, 20 by 20. And by default, let's put it at the origin. Okay. And can I set the fill color? Background. Set that to red. All right, so now I have a little red box inside of my touch view. Well, I'm going to create a new class, which is an NSObject subclass. Let's do that. Objective-C class. And we're going to call it touch responder. And that should be UIKit. And what this is going to do is it's actually going to listen for the touch events and tell the subview, tell the little rectangle to move around. Yeah, so this is a UI view. And I'm going to give it one outlet, which is the IB outlet UI view. And it's my little stalker. It's my stalker. All right.
Question back there.
Yeah.
So I noticed you replaced Coco there. Is this something we're just going to get used to doing?
Created from under the iPhone template.
Oh, right. So yeah, let me sidetrack on that for a sec. So, you know, I created the file and it said Coco by default. And do you have to do that every time? No, but I actually chose it from Mac OS X, and I should have chosen it from Coco Touch classes. And there's an NS object over there. So that when I create it that way, it'll actually say UIKit instead. So, okay. So I have one outlet in my touch responder, and it's the stalker, little stalker rectangle. So now I'm going to go back to. Let's make sure that's saved. I'm going to go back to Interface Builder. And I'm highlighting the big view that I stuck inside my window, and I'm going to change the superclass. Change the class, sorry. And it's called Touch Responder. And that automatically, you see, has an outlet called Stalker. So I'm going to drag. This is a throwback to Evan's first lecture, by the way. Oh, yeah, that's right. Yeah. Where's my window? Okay, so I'm going to drag from my view, to my subview, and I'm going to set it as stalker. So now this guy, my touch responder view, which is just this big white view, has one outlet. It's the stalker rectangle. And what should I override here? How about a touch? Did a touch moved? Or touch down? So what is that? Touches. You know what? I'm going to pull up my help. Documentation. Okay, so I'm going to go to my UI responder class. I don't remember the exact syntax for that touches began. So I'm going to say touches began. I'm going to copy that. And I'm going to override that one method here. Oh, yeah? We have a theory that we might have to do all three. Touches began, touches ended, touches moved. I'm going to try just touches began for now. Actually, let's do all three. It's only a second. This is on-the-fly coding performance at its best. So these are empty. Yeah, I'll change them. So this is touches ended, and this is touches moved, I believe. So touches began, touches not canceled, ended, and touches moved. Perfect. All right, so here's what I'm going to do. In my touches began, I'm just going to take the point that I click on and tell my stalker object to move to that point. So what I'm going to do is I'm going to start an animation. So UI view, begin animations. You notice that it automatically completes that for me, which is pretty convenient. I'm going to call this stalker. Stock. Is that how you spell stock? Stock? Stock. Context, nil. And here I'm going to say UI view commit animations so that when it's done, it's done. It actually starts the animation. And I'm just going to say stalker dot center equals how's that? UI. I could probably get it off the event.
You got the right touches, so the set of touches right there.
Okay, so I have a set of touches here. Basically, when this gets called, it has a set of all of the touches, all of the fingers that are down. It's a set, so I'm going to take any object from that. We'll assume it's only one. So let's do that here. NS touch. Oh, sorry, UI touch. Touch equals touches, which is the set. Any object, so just give me any object in that list. And I'm going to say stalker.center equals touch dot location in so then it's a function. What do you want? Location in view, right?
There you go.
Location in view and itself. So I'm asking the touch for the point that it occurs inside of a particular view, and it automatically maps the coordinate system.
Set the duration, just to be clear.
Okay, sure. UI view, set animation duration. I'm going to set this to 1 second. So it'll give me enough time to go and interrupt it. And I think that's it. Let's let it rip. So I'm going to run. Yeah, I haven't even saved it. No errors. I'm so proud. Okay. So, oh, look at that. So it actually snaps when I click. But there's some quick animation. I think this is just a setting.
Yes, that begins from.
Right. UI view set begins.
Set
Animation begins from current state. We set that to yes. And run. See, I hear people giddy with excitement. So, you know, as I'm clicking around, it just changes its position to where I click. Click, 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 click. And that's a pretty cool example, actually. I like that. Yeah. The question is, if a view has bounds and it can draw outside of it bounds, what does it actually mean? And yes, I believe what happens is you can't receive touch events. You don't, by default, get touch events if it's outside your bounds. I believe that's true. What happens when a touch event comes in is the view hierarchy takes a look at the point and it tries to map it to what's underneath it. And if there's nothing underneath it, it goes and asks, you know, is this point inside of you? Is this point inside of you? Is this point inside of you? To all the views in the subview. So that might be a side effect of trying to draw outside the bounds, is that you might not receive touch events.
And obviously, I guess you can't even, it doesn't even necessarily cover only its bounds, right? Because you can even draw a larger rectangle than its bounds.
That's
Am I on the mic?
Two.
Typically, you're not going to, from within your view, you're not going to just blatantly draw it outside your own bounds. Probably the more common thing is that one of your subviews might be positioned outside of your bounds. You know, it's let's say that this white view here was a little smaller, and the little red bouncy ball decided to draw outside of it for some reason. You know, that is enabled, and that is, you know, somewhat common, I would guess. But you're probably not going to just go drawing outside your bounds willy-nilly for no reason. More often, you would just make yourself bigger. So, if that makes sense.
Just trying to see how the size of a view is not just a suggestion in a sense, since you can ignore it, go bigger, smaller. And maybe the answer is the touching issue. If that's not a suggestion, it really won't be sensitive outside touching. Other than that, it sounds like visually you can do whatever you want. It doesn't really matter what it thinks its size is, right?
Yeah. I guess it really is just a repositioning of the coordinate system rather than a limitation. Now, there may be some limitations that come along with that. We can look into that, but I have to look offline for that. So this will be up on the App Store next week. I'm going to be make millions, man. All right. So that's it. Thank you very much, everybody. Good luck on assignment 3. Let us know if you have any questions.
For more, please visit us at stanford.edu.